Hey everyone, we are back and Miguel's with me again
Hello.
for day 6. We got all our little lovely stars and excited to see what this one's gonna be.
Yeah.
Alright, shall I give this one a read through?
Yeah. We're doing Advent Code Day 6
Yeah.
with Cybrand.
Day 6, Tuning Trouble. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way towards the Starfruit Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says it has many fancy features, but the most important one to set up right now is the communication system. However, because he's heard you have significant experience dealing with signal based systems, that's giving me a link to 2016 Day 6. Wait, I don't think I did 2016. I think I started doing it
There's
2018.
several links there.
Oh, there's several links.
Significant
Significant
experience
experience. Oh, geez.
dealing with.
16 day
Oh yeah,
6, 16 day 25, 19 day 7. I did do 19. I think I did
they
19
went
in Rust.
they went full in on the DSP PTSD.
He's heard you have significant experience dealing with signal based systems. He convinced the other elves that it would be okay to give you their one malfunctioning device. Surely you'll have no problem fixing it. Surely. Hey, VZW Grey, how's it going? As if inspired by comedic timing, the device emits a few colourful sparks. There we go. To be able to communicate with the elves, the device needs to lock on to their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects a start of packet marker in the data stream. In the protocol being used by the elves, the start of a packet is indicated by a sequence of 4 characters that are all different. Okay. The device will send your
Ah,
subroutine a data stream buffer, which is a puzzle input. Our subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such 4 character marker. Okay. So, given big jumble of characters, after the first 3 characters have been received, there haven't been enough characters received yet to find the marker. First time a marker could occur is after 4 characters, which would be MJ, QJ. But because J is repeated, this isn't a marker. The first time a marker appears is after the 7th character arrives, which is this one. Once it does, the last 4 characters received are J, P, Q, M, which are all different. In this case, your subroutine should report the value 7 because the start packet marker is complete. Okay. That makes sense. So we take a sliding window of 4
yeah. I
characters.
know. I think I know the code in BQN actually, but yeah, this is a brief one if you know the function for the sliding window.
Yeah,
Otherwise, you're not gonna have a good time. Do
sliding
you
window
know
and
the
then uh
is unique on the first 4, and then you find first. So you take the sliding window, and then I have a function that gives me the index and then the elements for a given iteration protocol. So if the element fulfills the criteria I want of finding that they're all distinct.
yeah, I've got a thing called um adjacent view, which will give
Adjacent.
me the 4 a sliding window. It'll give me back a
Mm.
tuple. Um, I guess I can just like convert the tuple into an array, do a sort, find adjacent. Um,
Oh no, you don't have a unique function for 4? Or
uh,
and then you check for the length?
no, no,
That's unfortunate.
not as far as I'm aware. Maybe I'm missing something, but we'll see. We'll see. All right,
All right.
let's
And
get
all
started.
right, enough spoilers, enough spoilers. All right.
See the other side.
Yes. Uh, uh, uh.
Okay, let's get going with day 6. Why are you taking a while? Hey Miguel, can you mute on Discord? Oh, I got a bunch of stuff from work I was doing earlier. Then new day. Okay, day 6. Let's go. So we're gonna do adjacent. We're gonna read in our string. We're gonna do pipe to TL views adjacent 4, and this should give us a sliding window of 4. Then we're gonna find if can use the standard version, std views, find if, and we'll say are unique, and this will give us back an iterator into this. So maybe we want to say Windows is this, and then we're gonna pipe Windows into our find if, and this will give us back marker position, and then we're gonna output the distance between begin of Windows and our marker position, plus 3, plus 4. I don't know, we'll see. Okay, so then we just need our unique, which is going to return a bool, and this is going to take a std tuple of chars. So I guess we can. What's the difference between a range and a view? A view is a kind of range which is non-owning generally, and can be constructed and deconstructed, and constructed and destructed, and copied and moved very cheaply. So it's basically like a view at some existing range, which is doing some kind of modification. So I guess I can convert this into an array and then sort it and then use find adjacent. How do I convert tuple into an array? I guess I use std apply and do some nonsense. Std apply takes a tuple and applies a function using the tuple as arguments. Std make array chars. Yes, exactly. TL views adjacent is like std view sliding, but with a fixed size window. Okay, that should be our array. Can sort our array and then return whether std ranges. Is this find adjacent? Is that thing? Oh, I already have it in my search history. I must have used this not too long ago. Adjacent find. Adjacent find. And what does this take? Takes our range, a predicate which defaults to equal to, and a projection which defaults to identity. So I should be able to just do that to find if there's any equal adjacent elements, and I return the negation of that. Let's give this a shot. May well have an off by 1 here. Oh, and it helps if I actually pipe my data in to my adjacent view. Come on. Oh, did something get updated in VC package? Looks like it. Anyway, the basic idea is take a sliding window, find the first one where all the characters are unique, which will give you the start of the marker, and then increment the marker to get our answer. And our unique just converts our tuple into an array, then sorts it, and then uses adjacent find. Visa W, great. I saw you released an album recently. Congrats. Yeah, thanks. It's on Bandcamp. You can get it here. Void River is what I'm releasing under. I used Ableton. I really like Ableton. It's really, really fun to use. The cover art was done by Marin Pan. It's really beautiful. I love it. This is still going. I don't know what I changed in my VC package configuration, which is making it like reinstall the world. It's currently building MD span. Right, let's have a look. What's our data going to be? Just a long string. Like part 1 you could almost do by eye. It's it's not really that much. I think that the part 2 is going to add something quite different, because this is saying that it's like a marker for something. So I'm guessing it's going to be, part 2 is going to be quite different. Ableton's also written in C++, which is fun. Make array is not a member of std. Also need algorithm. Didn't save it in time. Try that again. Make array is still not. Is make array not a thing? Oh, it's not a thing. Std. Does this work with compiler template argument deduction now? Constructor template argument deduction even. I also need tuple. Use of undefined type tuple size. Is that in type traits? No. Where am I getting this error from? Oh, this is wrong. SID ranges find if with our windows and our unique. Okay, I'm still trying to call tuple size on our lambda. Find if a range predicate. What's going on? Windows is an adjacent view. Our unique. Oh, it's expecting a binary function, right? Find if, yes. So I can pass it, what I pass here? Just did equal range is equal to. Hey, stool penner. Try that. I'm doing something wrong here. What am I doing? The predicate is a unary predicate, or indirect unary predicate. So, like that, this should be fine. I don't know what's going on. I want to see my mistake. Callable and tuple are the wrong way around. Oh, and my cultist did apply. Right, so apply takes the function first. Silly mistake. Okay, we're getting there. Initialization requires brace list. Nope. My monitor just turned off and it's back. Okay, getting there. Adjacent find returns an iterator, so we want to say equals end of the array, because we don't want to find any adjacent equal elements. Okay, finally we built. See if we get the right answer. Did I put anything in my input yet? Let's see. Oops. Okay, so we're hoping for what, 7? 6. I was off by 1. Let's throw out a few more of these just to make sure that we're looking okay. This one should be 10. Okay. Let's try for realsies. $1,100. Seems like a lot, but let's give it a shot. Yay! Okay. Let me just tell Miguel that we are done. Hey, we're done part 1, moving on to part 2. Okay. So my device's communication system is correctly detecting packages, but it still isn't working. It looks like it also needs to look for messages. A start message marker is just like a start packet marker, except it consists of 14 distinct characters rather than 4. Here are the first portions of the start message markers. Cool. So this would be easier if I had a runtime sized thing, so I could just get an array back. You know what? If I make this just auto, and I still need to pass the tuple in there. Let's just do, this is our unique for char. And part 2 is exactly the same, but I do shenanigans. 4, 8, 12. This is where we keep the good code, folks. This is horrible. Shouldn't be doing this. Yeah, if I had a sliding view which took just a runtime sized argument, I would get back vectors and I could just do it without dealing with tuples. But implementing sliding view with a run sized size is actually kind of difficult to do it properly in all cases when you've got like all the different kinds of underlying ranges. So it's kind of difficult. Oh, not the right answer. Plus 14. So just this, but plus 10. 39 seconds left away. Okay, well that's doing that. You know what, I can maybe clean this up slightly. like doing changing all of these into arrays in here. Does that work? Fuse transform this is gonna take our tuple and it's gonna change it into an array. Let's make this a function. Tuple to array takes our tuple type and oops. And if we really want to do it properly, then okay. Tuple to array. And then our unique is just going to take std array of chars of some size, sort it, JSON find, and then this is going to be the same as this, but with 4. Let's see if that builds. Why don't you write unit tests for this kind of series? Could do. Would be better likely. Oh, whoops. Oh, and of course can't pass tuple to array just like that. We need to make a lambda out of it. I've got something for that. Did I call it lift? Utility. Where's this? Everything called lift, which will just make a lambda out of an arbitrary function name. Where did I put it? Functional. It basically just takes this name, which represents an overload set, and then returns you a closure object, which represents it. Oh, and this no longer needs to be all that mess. This is now just, oops. Identifier not found for lift. Oh, TL lift, yes. Try it again. While it's building, let's just go and what was it? 2421. That's the right answer. Nice. We just finished the second part. Yep, just finished. All right. Miguel's finished the first part, so I can show what we've got. We did a bit of shenanigans. Our shenanigans have improved since we started, but so basically um I take our data, I you get a window of size 4. Um, I then that gives me back tuples for each window, which I then convert into arrays using this tuple to array thing, which is nonsense. I then find um, a unique one, which uses it just sorts the array and then checks if it makes sure that there's no adjacent elements which are equal, and then I just return the distance from the start up until the marker position plus the size of the marker.
All right, all right. I am finally looking at your screen. Sorry. It's there you go. You got the adjacent 4. You got the Tartan Llama lift, tuple to array.
Yeah.
Then you just find the unique distance marker plus 4. I did cheat. Wait, it's not cheating because you're using your ranges library. I pulled in an iter tools package, which lets you do the non-adjacent windows, or rather overlapping windows.
Yeah. Nice. Yeah, I
14.
some of this would be like slightly easier if I had a runtime sized sliding window view. However, I don't because it's actually quite difficult to implement properly.
Ouch.
Like you can do it. You can do a simple version which works for most cases fairly easily, but getting it to work in all cases and do it like be correct and efficient is actually quite difficult.
So 14 distinct characters.
Yeah. So basically, now I just tried to factor out both of my parts into a single function, and just call it with a different size of window.
Oh, answer too low still. Mm-hmm.
Let's see if this wants to build. There we go. All right, we're done. I'm reasonably happy with the solution that we ended up with.
Instead of 14, this should be 13 maybe.
All right, let's have a look at Miguel's code.
Darn.
So what do you have?
So I have I just start a normal counter. Then for each string in the string line in the input, this is my debugging printf with the at show.
Mm-hmm.
This is the part where I wrap the string into the non-overlapping windows, and now I'm gonna do size 14, and it's stepping one at a time. So this iter tools package lets me just do that. And also you have what's it called? Structured
bindings.
What's it called when you like you have in C++ where you can do like auto open square bracket
structure
a
bindings.
comma b. Structure bindings, that's the name. So you can do structure bindings for when you're doing the enumerate over an iterator, and so you'll get back the index and the element. So the index is the first one, the element is the second one. So I'll just check, hey, is the length of the unique elements of the window equal to 14? If so, please add the index plus 13, right? Because you're always looking up to, well, or like once it's on its way, you hit the condition once your index plus 13 is the character you're looking at, I think. but it's not right because I was just told, hey, Miguel, this is not right. Oh, is it?
Is
Oh
it
no,
plus
that's a
14 because it's one based in the puzzle?
Julia is one based.
Ah, okay.
Um, so that's why I'm doing is the length of the window equal to a 14th, and if so, well, yeah, the length of the unique elements of the window should be 14.
So how does that unique function work? Does it use a set or does it just compare all of the
I
elements?
bel
Or
I believe it uses a set. Here, let me show off something really cool after I finish this block. So if you never know how anything works in Julia, this is so that people can read this. I'm in the REPL, and so if I type question mark, then I'll do, hey, how does unique work? If in fact, if I don't even remember like what the name is, I'll just do uni, and then I'll do tab tab, and so I'll
nice.
get autocompletion. And then I'll do, hey, like, what's this unique thing, right? Let's try that again. There we go. And so I can scroll up and say, and see all of the like specifics and some examples on how it works. Returns an array containing only the unique elements of collection IT as determined by is equal in the order of the first of each set of equivalent elements originally appears. The element type of the input is preserved. Uh, this preserving the element type of containers is super duper duper important in Julia. It's also important for performance, but Julia has a specific twist on it. You can also use it with anonymous functions. So unique f into iter returns an array containing the value iter, and then turn the unique regions of A along dimensions dims. Oh, um, this one doesn't say. Oh, all unique. Is that maybe what I was
Maybe
looking
what you
for?
want, yeah. I mean,
Returns on true false values from iter are distinct when compared with A is equal.
looks good to me.
We learned something today. I've learned Advent of Code is so cool for. So if I do, yeah, and I already know that the length is 14, right? So I'll do all unique of the window. If all unique, yeah,
That's pretty nice.
yeah. There's like so many goodies
Mm.
in Julia, and so uh, hopefully this last one was like, hey, you didn't hit the condition. This one shouldn't have hit the condition because there's two
Two L's.
L's. Then this one should THMDZJZFLWPNRS. That looks all unique to me.
Looks legit.
So if we do 280, submit, not right answer, too low.
Have you tried with some
So
of the test inputs? Just for, as a
I oh
safety
right,
check.
that's what someone that's smart would do. Um, so let's see, that's test input number 1.
Mm-hmm.
First marker after the character 19. So that's my index plus 13. But I didn't keep that. So why did it not
Oh,
work with
you,
that?
yeah, you show index, but you don't show index plus 13, so the answer you typed into the website is off by 13.
Um, you're saying something that should be really obvious, but
So the
can you
you
say
you
it again?
show IDX,
Mm-hmm.
right? Um,
Uh-huh.
and that's what you're typing um into the
Mm-hmm.
website, but IDX is off by 13.
But I no, what I get back is the result thing.
But that's not what you typed into the website. You took your
I feel silly. I
you
feel
copy
very
pasted from
silly.
IDX.
Oh no. Oh no.
So you just need
So
to add
this should read
13 to the answer. Yeah. Yeah.
what's up? All right. So this is another one of those. I think this could be a one-liner. You want to help me one-lineify this and make it god awful? So let's do
Well,
flex.
there's only one line, right? So you don't need each line.
Oh, right. So I can just do, yeah. So, and then I don't even need the sum, right? I just need the, yeah, the
Yeah.
name of the index, I think.
Yeah.
So let's do first of 4 IDX when in enumerate iter iter tools dot partition, and then this is the input 14 one at a time, and then I want to keep for that IDX actually.
So what does flex do?
It flex is going to show that I can write this in a line. Yeah, it's just so flex here is just the name. IDX for, oh, it's IDX plus 13 plus 13, right? Yeah, and then you can do the if all unique of window da da da, and so if I do flex of 0 6a, it didn't find anything. um how did I do
Your
the other
input's
one?
not a string, is it? That you didn't read your um
Oh,
you just gave
right, right,
it
right.
the name of the file. You didn't read the file.
Yeah, so if I do read input into string, I believe that, oh, 2193 2194. That's kind of weird. The right input's
Oh,
there. I don't know why.
it's because you're keeping on going, right? The problem wanted the first marker,
Oh, right.
and you've found all of the markers in the input.
All right. So let's do just is it first? Yeah.
Nice.
Ta-da. One liner for no reason at all. Just completely gratuitous. Yeah, sweet. All right, we both did it today. Oh Lord. Oh,
Success. Cool. Well,
yeah. And I learned about all unique.
yeah, that's
And
pretty nice.
this,
I don't think that there's a similar thing uh in C++. Like, um,
oh yeah, Rails time is in the chat. Great day for Julia and BQN. So Rails time, I don't think that I can pull out the BQN right now, but there's a, oh, actually, why not? Let's try it. Yeah, there we go. Can I do this? Line equals, and then do that. Here, can you read that?
yeah.
All right, it's funky single symbols time. So it is, my input is this one, or rather, yeah, that one. And so if that works, so this is my line. And then, okay, all my line. And then if I can do line, and then my windows is, let's say, 4. Right. So that's all you need for like overlapping windows in BQN. Just the the emoji for like up down arrow, and
Yeah.
then a digit on the other side, and then that's your non-overlapping windows.
Nice.
Sorry, that's overlapping windows.
Overlapping
So
windows.
now you want to map to each of these rows. There you go. You want to map to each of these rows if they're all unique. So I think this is like that. Grouping argument must consist
Really
of
sorry, the boiler
integers.
guy's here.
Oh,
The boiler guy's here.
I need to go because our boiler's getting fixed. See you all.
Oh yes, get